We can add to the list, so if you have questions that we don't have up here, feel free to throw them in. The first question that I definitely want to talk about is number 3. So our equation is y equals 3x squared plus 7. And I want to know about the symmetry. You have 2 options for this. We talked about the algebraic way. So to check the x-axis, remember you replaced your y with a negative y. To check the y-axis, what do? Replace x with negative x. To check origin, what do? Both. So we can do it this way. If you look at the x-axis, we just have negative y equals 3x squared plus 7. Is there anything we can do to make that turn into the original? No, so it's not symmetric to the x. To check the y, if you take negative x times negative x, what does that turn into? Positive x squared. Is that what we started with? Yes, so it is symmetric to the y. Origin, we do both. So negative x times negative x is positive x squared, but we still have this negative y, so it's still not what we started with. That's the algebraic way. What's the other way of deciding this?
If you want to square the x, why do you still put the square symbol?
Because when you take negative x times negative x, so the negative times the negative is positive, but x times x becomes x squared. You're welcome. What's the other option?
Graph it.
Yeah. Do we know what 3x squared plus 7 looks like? We should. It's x squared is a parabola, so we know if we're doing a really rough sketch, we know a parabola looks like this. If you multiply it by 3, what does that do to our parabola? Stretching, it's getting skinnier. What's the plus 7 do? Up 7. So we have this skinnier parabola up here. Okay, now could you do more exact points if you wanted? Absolutely. But if you look at this graph, if I flip that thing over the x-axis, does it overlap itself? No, if I reflect that over the x, it's going to come down here. So that's definitely not the same. If I reflect it over the y, does it overlap itself? Yes. If I take this part, flip it over the y, it comes over here. So it overlaps. So that's a yes. Origin is both. If I flip it over the x, comes down here, then flip it over the y, it overlaps. But again, that's not what we started with. So it's y-axis only. If I put this on the test, I don't care which way you do it. If you do it the algebraic way by putting in the negatives for the opposite variables, or if you use the graph. But I will tell you, you have to justify your answer. So if you're saying you're using a graph, you need to draw me a picture of your graph. Okay, at least a rough sketch. If you're doing the negatives, you need to show it. If you just put yes, no, yes, or whatever, that's wrong. You have to show me something for why your answer is what it is. Does that make sense to everyone? So, do you feel confident if I gave you something like this on the test, you'd be okay? Problem 5. My favorite, the greatest integer. So we have f of x equals greatest integer of 1/3 x with a minus 1. Alright, what is our strategy when we're doing greatest integer functions? Can I just plug in 0, 1, and negative 1? No. What do I have to plug in? Decimal. So we usually did like 0, 0.5, 0.9, and 1. And see if we could get it from there. So if you put in 0, 1/3 times 0 is 0. Greatest integer of 0 is 0. minus 1 is negative 1. Got that point out exactly, so it is a closed circle on my graph. If I put in 0.5, 1/3 times 0.5 is 1/6. What is the greatest integer of 1/6? 0 minus 1 is still negative 1. Okay, so 0.5, I'm still down here. If I put in 0.9, 1/3 times 0.9, what's that give me? Okay, and the greatest integer of that? 0 minus 1 is negative 1, so I'm still down here. Okay, if I put in 1, 1/3 times 1 is only 1/3. What's the greatest integer of 1/3? 0 minus 1 is still negative 1. So that's kind of unusual. Usually at this point we jump up a step, and it hasn't jumped yet. So we are still down here. What if I put in a 2? 1/3 times 2 is 2/3. What's the greatest integer of 2/3? 0 minus 1 is still negative 1. So at 2, I'm still down here at negative 1. If I put in a 3, 1/3 times 3 is 1. So now we have the greatest integer of 1 minus 1. Since 1's an integer, we get 1 out. 1 minus 1 is 0. So that is where my step jumped. Because when I put in 3, I got out a perfect integer. So we're on this step until this point, so we end it with an open circle and we jump up. So now we can see our step is 3 units long. Close on the left, open on the right. How many steps minimum do I want you to draw? 3. So you can extend your pattern either way. And you guys have a graph, so if I give you graph paper, it's not too hard to keep going. So either carry your steps all the way to the end of the graph, or if you only do 3, at least put ... so I know you recognize this isn't the end, it keeps going from here. Any questions on that one? Okay. Number 6. We're still having a little trouble with these piecewise functions. At the end, remember, this is a function, so it has to pass the vertical line test. If you're looking at your graph and it fails the vertical line test, you've made a mistake somewhere. What strategy do we use for graphing these? What have I told you to make? T-chart, 1 for each piece. What do we have to plug in first? 0, because that is the beginning. But because it doesn't have an equal to, when I plug that in, it will be an open circle. Now, this is where people are making mistakes right now. X has to be less than 0 for this part. So the other x's I choose have to be smaller than 0. Okay, so the opposite of 0 is 0. Opposite of negative 1 is 1. Opposite of negative 2 is 2. Sometimes people are struggling after they get these points. So if you need to, go ahead and graph this as you go. So we have 0, 0, negative 1, 1, negative 2, 2. It started here. It continued for everything less than 0. So it doesn't have a stopping point. So this section keeps going. So the next one. We also have to start at 0, but because this one had an equal to, it will be closed. And then my x's have to be greater than 0, so we plug in things bigger than 0. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4. What if you already have an open circle there? Do you draw, like, sometimes I have people draw something like that? Is that what I want? No, if you have an open and a closed at the same place, it just becomes closed. So 0, 0 becomes a closed circle. 1, 2, 2, 4. So it looks like that. how do I look at this and tell if it's a function? Yeah, remember your vertical line test. If you can draw a vertical line and it ever hits it more than once, it's not a function. So do that as a quick check at the end to catch any mistakes. If I ask you questions like domains and ranges from looking at graphs, can we handle that? Domain is the x, going left to right, range is your y, going bottom to top. Increasing, decreasing. What's this graph doing first? Decreasing from -infinity to 0, and then it is increasing. When you tell me increasing and decreasing, make sure you're using the x values. The only time we use y is if we're talking about a range. Okay. Let's look at problem number 8. So another piecewise function. So this time, we need 3 t-charts. First one, what's the first number you have to plug in? -4, and is it open or closed? Open because it doesn't have an equal to. And then the other numbers I plug in are less than. Okay, so 2 plus -4 is -2, 2 plus -5 is -3, 2 plus -6 is -4. -4, -2 is open. -5, -3, -6, -4. So it started here. It continued for all x's less than that, so it just keeps going. Next piece. This one's a little bit different because I have a starting and a stopping point. So we have to put both of those in, and then just something in the middle. -4 had an equal to, so that's closed. But 2 did not, so that one will be open. And we're getting the opposite of x. So opposite of -4 is 4, opposite of 0 is 0, opposite of 2 is -2. So, -4. And we have to check. We can't have 2 closed circles in a spot because it's vertical line test, so we're okay. 0, 0, 2, -2 is open. Because this had a stopping point on both ends, it's just a segment. This one, start at 2, equal to is closed, and we want things bigger. So 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Two, 6. 4, 12. This started here and was for everything greater than 2. So it just keeps going. Is this helping, guys? Any questions there? Problem number 9. This is one of our basic functions. So do you guys remember all the basic functions? Do we need to kind of run through those real quick? Things like x squared, x cubed, square root, cube root, absolute value. Am I missing anything? Might be all of them. So any of those were the ones that we used on the front page when I was asking you to make your rough sketches. Those I'm expecting a parent function. And when I say parent function, that doesn't just mean a single point. Okay. can tell me.
Expect
Okay. So we're starting with this x cubed. That's our parent function. And I want at least 3 points. More if you're not sure about your graph. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. -1 to the third is -1. -2 to the third is -8. Now you can use your calculator if you need to kind of confirm those points. And when we graph the parent function, we always do it dashed. Now, let's go through. What are my transformations? What will that negative do? And what does the -4 do? So if I take 0, 0, it's on the x-axis, so when I reflect, it doesn't go anywhere. And then down 4. Okay, when I take 1, 1, when I reflect, it goes to 1, -1, down 4. When I take 2, 8, and reflect, it goes to 2, -8, and then down 4. If I take -1, -1, and reflect, it goes up to -1, 1, and down 4. If you did -2, -8, it goes to -2, +8, and then down 4. So I should be able to clearly see at least 3 points on both your original and your final graph. Are those okay? Then we got into our function stuff. So number 12. We know f of x is 3x squared minus 2. G of x is 4x plus 4. So when I ask for f plus g of 0, what that means is you're going to put 0 into f and 0 into g, then add those answers together. Okay, if you put 0 into f, that's 3 times 0 squared minus 2. So 0 minus 2 is -2. If you put 0 into g, 4 times 0 plus 4. So 0 plus 4 is 4. So -2 plus 4 gives us 2. So plug it into each. I would recommend on the test, you don't have to show me all your work, but I would at least maybe write this line and this line instead of only the final answer. Then I can see, oh, well, maybe you plugged it into F correctly, but you made a mistake on G, and I would only take off for that instead of all the points. So at least kind of give me an idea where you're getting your answer from. Is that one okay? So 13 tells us we want f divided by g of -2. So that means you put -2 into f, put -2 into g, divide your answers. So if I put -2 into f, and -2 into g, -2 squared is 4, times 3 is 12, minus 2 is 10. On the bottom, 4 times -2 is -8, plus 4 is -4. So -10 over 4, you could reduce it to -5 over 2, or say -2.5. Either one is fine with me. So in those cases, you're just plugging the number into each and getting your answer. On problem 14, I'm asking you for for a domain of g divided by f. So if I did g divided by f, that's 4x plus 4 over 3x squared minus 2. Everybody should be able to tell me at this point, if you have a fraction, what's true? Bottom cannot be 0. So 3x squared cannot be 2. So x squared cannot be 2/3. Yesterday I was helping a lot of people who got stuck at this point. How do you get rid of a square? Square root. If you add a square root into your problem, what else do you have to include? Plus and minus. So x cannot equal plus or minus. Okay, 2/3 does not have a nice square root. I want the exact answer if at all possible. We could say that's the same as the square root of 2 over the square root of 3. You guys agree with that? It is not proper notation to leave a radical on the denominator. So how do I get that off? So we have x cannot equal plus or minus square root of 2 times square root of 3, square root of 6. Square root of 3 times the square root of 3 is the square root of 9, which is just 3. So x cannot be plus or minus radical 6 over 3. Usually I'm expecting interval notation for your domains, but I've told you if it's more than one thing that x cannot equal, you are allowed to just list it like this. Any questions there? I added 16 to the list because I thought we should look at that one. So it wants f of x plus h minus f of x over h, and we know we're still looking at f of x being 3x squared minus 2. Alright, I have told you that on the test, I would actually separate this into 3 questions. I would say f of x plus h, part B, f of x plus h minus f of x, and part C, the whole thing. So you can expect to see it like that. F of x plus h. If I said f of 5, you would go to your equation and replace your x with 5. So when I say f of x plus h, we are going to the equation and we are replacing x with x plus h. When I say x plus h squared, that means there are 2 of them. So if we FOIL those, we get x squared plus xh and plus xh. So we could add those to 2xh plus h squared. Still have that minus 2 on the end. Distribute the 3, so we get 3x squared plus 6xh plus 3h squared minus 2. That's the first part. And that should be the longest part. Every step after this should get easier. So part B, it says f of x plus h. That's what we just found. So we carry down that answer. Minus, what is f of x? The original. So if we distribute our negative, positive 3x squared and negative 3x squared cancel, negative 2 and positive 2 cancel, and all we are left with is 6xh plus 3h squared. Part C is the answer we just got divided by h. I have seen a couple mistakes here. If I had like a +1, could I take h out of all of those? No. If you have something like that, you've made a mistake. When I get to this point, what's happening is on the top, they both have an h. I could really factor out that h. Then these h's cancel. So we get 6x plus 3h. Is that okay? Make sure you're correcting if you missed anything here. Alright. Problem 17. F of x is -2 for x minus 5. G of x, square root of x plus 6. So part A, I want the domain of f. F is a fraction. If we have a fraction, what do we know? So that means x cannot be 5. So to write that, it's everything except 5. -infinity to 5, union 5 to infinity. Because it's only one value, I expect that interval. If you just said x cannot equal 5, I would take off 1 on the test. I do want the interval here. B is asking for the domain of G. If we have a square root, what has to be true about anything under a square root? Those are the only two domain rules. If it's a fraction, the bottom can't be 0. If it's a square root, whatever's underneath has to be positive. So x is greater than or equal to -6. So our domain, it's everything greater than or equal to -6. So it starts at -6 and goes to infinity. Part C. G composed with f of 1.5. That means G of f of 1.5. You start on the inside. And this seemed to really throw a lot of people, but I think it was just because it didn't work out nicely. Okay, so we would have -2 over -3.5. If you put that in your calculator, it's going to turn it into a fraction for you, or a decimal. You get 4 over 7. Okay. So now, I'm going to take 4 over 7 and put that into G. G is the square root of whatever we put in, plus 6. This does not work out beautifully. You get like the square root of 46 over 7. I told you guys, when people were asking me, you could give me the decimal. I didn't care. So if you just type that on your calculator, you get 2.5635. Otherwise, you could rewrite it in radical form, but I would take either one here. All right, so don't let it scare you off just because your number didn't turn out pretty. Same idea. D, f composed with G of -2. So that's f of G of -2. So if we put -2 into G, it's the square root of -2 plus 6. What's -2 plus 6? 4, and the square root of 4 is 2. So now we have f of 2. So if I put a 2 into f, we have -2 over 2 minus 5. So -2 over -3, or positive 2/3. Is that okay? You guys still with me? Is this still beneficial, seeing these? Okay. 19. I can promise you, I am going to put a question like this on the test. And a lot of you are not getting these correct, especially the domain part. So let's take a look here. In order to find this domain, we need the composition. G composed with F. So G of F of X. Start on the inside. F is 3 over X. I am putting that into function G. So 5 over 3 over X minus 1.
Is F 3 over X? So you put
Yeah, so it asks for, okay, so you start on the inside. And F of X is 3 over X, so that's what goes on the inside. And then you're taking that and putting it into G. So I look at G, where that had an X, I put the 3 over X. Why can I not leave this as my final answer? It's a fraction and a fraction. So our strategy is to multiply top and bottom by the denominator, which is just X. This is one place where I'm seeing mistakes. 5 times X is 5X. On the bottom, you have to distribute. 3 divided by X times X would give us 3. But you have to take it to the 1 as well. Minus 1 times X is X. So that's my composition. For the domain, we have to look 2 places. The final answer is one of them, but what's the other one? The original inside. Okay, I have a fraction. I know in a fraction the denominator can't be 0. At the end, I have a fraction. Denominator can't be 0. So for my final domain, I put them together. So X can't be a 0 or a 3. And since it's more than one value, you are allowed to just leave it listed like that. All right. Number 20 is another piecewise. We've covered a couple of these so far. First part is just testing if you understand how to read a piecewise. If I say f of 4, if x is 4, which rule can you use? Is 4 less than 4 or greater than or equal to 4? Greater than or equal. So you plug it into the second one and you get 2. If f is negative, x is negative 6. Negative 6 is less than 4, so you put it into the first one. So negative 12 minus 3 is negative 15. If x is 5, 5 is greater than 4, so you put it into the last one, and we get 1. Is that part okay? Then we graph it with the t-chart. Remember, you have to put in the 4. The first piece, we want things less than that. Because the 4 didn't have an equal to, it's open. So you put that in, you get 5. 6 minus 3 is 3. 4 minus 3 is 1. So it started here with an open circle. 3, 3. 2, 1. And it's continuing for everything less than 4, so it keeps going. Second piece. Greater than or equal to 4, so we put in 4 and things bigger. So if we put in 4, we get 2, 5 gives us 1, and 6, 0. So 4, 2 is closed. 5, 1, 6, 0. Look like that. Are we okay there? And so then I asked you some questions. Increasing. You have to give me the x's, so it's coming from negative infinity. It stops increasing here, which is when x is 4. It was an open circle, so parentheses. Decreasing, it starts here when x is 4, and it falls forever. So You guys okay with increasing, decreasing? Constant is like a horizontal line. We don't have any of that here. I asked where it's continuous. Is the whole thing continuous? Remember, continuous means you can graph it without picking up your pencil. So if I'm graphing it, I'm coming from negative infinity. When I get to 4, I have to stop, pick up my pencil, and jump down here. So then it's continuous after that. So it's continuous everywhere except that 4 because we had the break in our graph. Any questions about that? Um, 22. I'm going to try to quickly get through these. So even, odd, and neither. So remember on these, what we did, it's like symmetry. So we replace our x with a negative x. If you get the same thing you started with, it's even. If you get the exact opposite, is odd. Opposite, odd. So if I look at this, if you take a negative to the 5th power, is it positive or negative? Yeah, if you have 5 negatives, it's still negative, so we get a negative x to the 5th. If you have a negative cubed, is it positive or negative? Negative. So negative 2 times a negative x would make a positive 2x cubed. So even means it's exactly what we started with, is it? No. Odd is the exact opposite. If I came through and took the original times negative 1, and that's what we have here. So this is odd. The last ones, make sure this last section you guys didn't ask many questions. You'll have several absolute value equations and inequalities, so make sure you know how to do those, know the difference. Less than is an and, greater than is an or. You guys remember that? With the equations, you always make 2 equations. The first equation, nothing changes. With the second equation, we always set it equal to the negative. In this case, we're just going to take a negative to this entire side because it's multiple terms. And then you solve both of these. So over here, if we subtract our 3x and our 11, so we get 4x equals negative 12, so x is negative 3. Side, if you add over your 3x, subtract your 11, and we get negative 1. And if it's an equal to, your answer is a solution set. It's just these numbers. When it's an inequality, you have an interval. Are there any other questions?